All right, good morning, guys. We are on lesson 15, distinguishing volume and surface area. So our last two lessons here are going to go a little more in depth. No real new information. I will give you one additional formula for surface area. But it's just, do I use volume? Do I use surface area? Can I use both formulas to solve it? So this first question here, we're on page 119. It says, Maya's science teacher told her that when there is more ice touching the water in a glass, the ice melts faster. She wants to test this statement, she does a little science experiment. She begins with 2 cups of warm water, and in 1 cup she puts an ice cube, in the second cup she puts crushed ice. Okay, we were going to have a discussion in class here. I'll just kind of have you think out loud. Which one is going to melt faster? The cube or the crushed ice? Okay. And then which one is your hypothesis? That means what's your educated guess, scientifically speaking. And will the ice cube or crushed ice melt faster, same rate, and explain. Well, hopefully you know that the crushed ice should melt faster. Okay. It's going to have more surface areas, more spots touching the warm water. Okay, so using our surface area knowledge, when you have more ice touching the water versus a cube, just the outside's touching the water, the crushed ice is going to melt faster. Okay? If you have a cube and you surround it by water only, the outside's going to get melted by the hot water. If you have crushed, obviously, again, more surface area. That's all I wanted you to note there on the first one. All right, question number 2. It says the other day you calculated the volume. Now it wants us to figure out how much cardboard, so that would be the surface area of this box. A couple things to note on this. We did figure out the area of the base already a couple lessons ago. The area of the base was 40 from our notes. So to get the surface area, we are going to have the top and bottom box in cardboard, and then all the sides. Okay, so when we did this problem, we talked about how you can figure out the area of every side, and every side is going to be a rectangle with a height of 2. And now, however, there's only 2 sides that we for sure know. This is 2, and this is 2. The rest are diagonals. Okay, the rest are diagonals, so we need some tricks, and this book is assuming you already know the Pythagorean theorem. A squared plus b squared equals c squared. That's going to be a tool you're going to get in 8th grade. So I'm going to give you the diagonals here. Okay, I'm going to give you the diagonals. This side would be 6.4. Okay, and all the tops are going to be 2.2. You would not have to figure those out on a quiz or test or anything, but I'm just going to give them to you and a new formula for surface area. Because we could figure out the area of the top, take it times 2 because the height is 2. Area of this rectangle, it's 2, height of 2, 2.2, height of 2. Okay, here's a new formula I want you to write down. We can figure out the surface area by taking the perimeter of the base times the height. And that's just going to save us some time, guys. Instead of figuring out every one individually, 6.4 with a height of 2, 2 with a height of 2, and so on all the way around, I can add up all those numbers, take it times 2, and that will give me the area of all the sides. So we're going to use a calculator and add those up all the way around. So I have 6.4, 6.4. I have 2 and 2, that's 4. And up top I have 4 2 by 2s, so that's going to be 8.8. So adding them all up, I get 25.6. Okay, that's the perimeter all the way around. Remember our formula, we got to take it times the height. Height is 2, so take that times 2. So that's the area of all my sides, 51.4. So my base is 40. Again, we figured that out from our volume problem. Top of the box is 40, and all my sides are 51.2. So if you add 51.2 plus 80, you get a total of 131.2, and it's in inches, and it is area, so I do need to label it. Square inches, so that's how much cardboard is needed for all of you that bought your sweetheart a box of candy in a heart-shaped box over for Valentine's Day. 131.2 inches of cardboard needed. You do not have the cards needed for 15.3, so we are going to skip that. Go ahead and look at bottom of page 121. Wheelbarrows being used to carry wet concrete. Here are the dimensions. And then on the next page, it's going to talk to us about some volume and area. Okay. It says a wheelbarrow is being used to move wet concrete. Here's the dimensions. So remember, this is our base. This is what's going to have to stand on this end in order to make it a prism. And then they kind of took it out here for us nicely so we could look at that base. So these two pieces are the same. This one's obviously in more detail. Okay, so remember the first question was asking for volume. So we got to get the volume of this shape. Remember, volume is area of the base times the height. So here's our base. We got to get the area of this. Area of this times the height would be 70. Okay, so how do I get the area of this? Well, we don't know the formula for area of a trapezoid yet. So I'm going to break it up into triangles and rectangles. Okay, so 2 triangles and a rectangle in the middle. Now I should be able to get the area of that triangle. Base times height. 34 times 66 is the height, not 74, that's the diagonal. 34 times 66 divided by 2. 34 times 66 divided by 2 is 1122. Area of the rectangle in the middle, 66 times 40, not added, times 2640. And the area of this triangle. Now, the whole thing was 106. I know that this is 40, so I have to take 106 minus 40, and that is 66. So this side is 66 by the height of 66 divided by 2. 66 times 66 divided by 2. 2178. So those are all my sides. I can add them up. I get 5,940. Again, that is my area of the base. So next page, I'm going to put that down. Remember, volume equals area of the base times the height. Area of the base was 5,940. Do you remember what my height was? Because I forgot. 70. So 5,940 times 70. I get 415,800 centimeters cubed. Okay, so that means in that wheelbarrow, guys, remember volume means how much space it will take up. If you had a block of concrete that's 1 centimeter, 1 centimeter, 1 centimeter, there's 415,000 of them that can fit in that wheelbarrow. Okay, that's pretty crazy. Number 2, after dumping the wet concrete, you notice a thin film on the left side of the tray. What is the area of the concrete coating the tray? So now we've got concrete on the inside of my wheelbarrow, and I want to know how much is in there. Okay, the surface area, the area of every surface covered by concrete. Okay, notice obviously no top. The top on a wheelbarrow is gone, so you can dump the concrete out, so we do not figure out the top. So we're going to figure out the surface area of all the sides, and then we're going to have to subtract the area of the top, because there's no top on a wheelbarrow, obviously. So let's go back to our wheelbarrow. Okay, so I know the area of both sides, right? 5,940. So that's pretty simple. each side is going to be 5940. 5940. And now how do I get the area of the sides? Okay, how do I get the area of all the sides? Okay, we're going to use our equation that we just learned about, the perimeter of the base times the height. Okay, perimeter of the base, here's my base, remember? And I have all the sides, so I just got to add them up. Let's just start with 93 and work our way around. 93, 40, 74, 34, 106. 347 is my perimeter of the base. Okay, 347 is the perimeter of my base, times my height is still 70. Times 70. 24,290. Okay, so if I add those all up, 5940, 5940, I get 36,170. And now remember, I gotta subtract my top. So the area of the top of my wheelbarrow, it's gonna be 140 by 70. 140 times 70. 140 times 70 is 9,800. 36,170 minus 9,800 is 26,370, and that is area, so it is squared. Okay, so remember that formula, perimeter of the base times the height, comes in handy. That's the new one you learned today. And that should be it for the notes. Your homework starts on page 123 and goes to page 125. There are 5 questions for you. All right, that's it for today. Stay safe and stay healthy, guys. Take care.